Okay, nice and straightforward. Let's have a look at the specimen assessment material for paper 3. First thing to notice is your exam is going to be an hour and 15 minutes long, and right in here, every single question needs to be answered. Now, the paper is divided into 2 sections. I'm not going to go through the first section. That's the issue evaluation. That's the advanced information booklet. For those of you watching 2018, that is obviously the Abingdon Reservoir and all its glory. Remember, guard, group against, and etc., etc. So let's look at the section B. And again, remember, you've got to do every single question. And section B is where they examine the fieldwork. And I'm going to race you through a few of the questions that are asked and see how you get on with just understanding them. First thing to note is that it starts off by asking you about kind of random field work, then it asks you about your field work. And please read every single word carefully and everything in bold. Otherwise, you'll find when we look at the mark scheme, you'll miss out on things. So first things first, and I suggest you've got the link underneath on the YouTube clip to be able to get a copy of these, both the mark scheme and the question paper, and I won't waste too much time on the obvious ones. So the first one is they're giving you a physical resource, a valley, and they're giving you a resource of an urban area. Okay, 2 little pictures to stimulate you to think there's 2 different locations, a physical and an urban. And simply, the question asks, identify 2 data collection techniques that could be used to carry out field work in one of the areas. Okay, so you state your area like a river, and technique 1, measuring velocity of the river, measuring the size and average size of the pedals, measuring the width of the river, measuring etc., etc. And the mark scheme, it rewards exactly that, and you'll be able to see this in your own time, but essentially credit any techniques that might reasonably use to gather data: traffic counts, pedestrian counts, environmental quality, building height, etc., etc. Okay. Do note down here, as I did say, if you haven't noted the area that you're talking about, you can't get any credit in the mark scheme, and you don't want to be doing that. The second question in the SAM, specimen assessment material in the SAM, is one about data collection and data presentation, sorry. So this is an isoline pedestrian flow map for a part of London for 5-minute pedestrian counts, where somebody or the students have stood in places and counted how many people pass in 5 minutes. They've created a map which joins up places of equal number, an ISO line map. ISO equal line, it's a line. And you can see that the first question asks you to complete the map. Now, this probably is a clue as to the kind of question they're going to ask you anyway. Complete the graph for this data, complete the map for this, etc. Cheap marks, easy marks. With this type of graph, you've got a line that finishes there and a line that finishes there, and they want you to finish them off. How does it work? Well, look, somewhere between the pedestrian count there of 95 and the one down there of 117, you interpolate, guess, where 100 would it be? And it's probably closer to the 95 than 117, so it's going to be in between the 2 points. Here's 106 pedestrians, there's 200, so the chances are the 100 would be to the west of the 106 line. Similarly here, to the west. But here you've got 93 to 200, so in fact the line must kink inside, if you like, that 93. And if you look at the mark scheme, that's exactly what's happened. Following around the outside, in between, on the outside, in between, nice, easy mark. Okay, second question, describe the pattern. Remember, describing patterns is about maximum, minimum, trend, anomaly, but quote the number and locate it. In this case, you can use points of the compass, or possibly even you could use the actual names of streets and things. So describe the pattern of pedestrians shown. Here's what they say underneath. Credit statements about pedestrian flow patterns using information on the map. Greatest concentrations of pedestrians at the junction of Oxford Street and Regent Street. We can see that. Flows elongate along the roads, west to east and a little bit to north and south. Uniform reduction in pedestrian flows stretching from north to south. Okay, go back and have a look at it. Well, there it is. I'll show you the finished one. Very, very simple things. Describe questions. Meat and drink for geographers. Do have a look at a couple of things here. No credit for answers just listing or comparing numbers. Got to talk about pattern and describing a pattern. Because remember, all data presentation techniques are about showing patterns in data, which we can then analyze further with a bit of the old maths. Have a look at one of the links down below in the YouTube clip, and you'll see that I've put there quite a nice slide share which compares different techniques. Or you can use your textbook as a nice section on comparing data presentation techniques. Next question. Suggest one alternative method of presenting the information shown. Well, it's numbers on a map. And if we're going to present numbers on a map, another way to do it at each of those points is to put some kind of proportional scale symbol where the symbol matches the number. So, for example, a little bar chart, 95 there, 117 bigger there. They're called proportional symbols. And if you look at the mark scheme, that's all it's looking for, located proportional symbols. Quite straightforward. The key is not to freak out when you see it, because we can't predict exactly what they're going to ask, but it's going to be about something to do with comparing data techniques. Finally, a little bit more advanced, explain why the pattern of pedestrian flow shown in figure 8 may not be accurate. Well, it may be that people didn't measure them at the same time. Possibly 400 people walking past you in 5 minutes is too much and we miss people in groups. It may be that some people were not accurate and didn't record everybody. Straightforward errors that can happen in data collection. And if you look at what the mark scheme says, it gives quite broad ideas. Explanation must relate to accuracy. Accept 2 single comments or 1 developed. Remember geography, simple comment or this, therefore that. So simple statements. Cannot guarantee exactly 5 minutes were used by everybody. Some students may have started counting earlier than others. Actual counts might not be accurate. Those are simple statements. 2 of those, 2 marks. Here's an example or set of examples, but again, look for yourself at the mark scheme of a developed answer. Cannot guarantee that exactly 5 minutes were used at each site, therefore cannot make the fair comparison. And that link sentence, an examiner is trained to look to think that's a 1 plus 1. That's a develop point. You're trying to go for those, what I call arrows. Therefore, this means that. This will result in. Nice and straightforward. Okay, so that's question 4.5. And then we get into a question on data. So as part of, I'll just go past this, as part of an inquiry collecting physical data, a student measured pebble sizes on a beach. Excellent. 11 sites, 11 sizes, and guess what they did? They created a dispersion graph where each pebble has been given a cross, and where 2 pebbles were the same size, one goes next to it. And I bet you the first question is complete it. So you've got to find out which of these pebbles is not on this dispersion graph. I'll tell you it's the 7. And if you look at the mark scheme, they'll tell you as well it's the 7. And you can see it's nice and big there. 1 mark. Easy street. Okay, going back to the question. Again, suggest one way in which the data collection technique could be adapted to make the sample more reliable. How do you make a sample more reliable? Make it bigger, possibly. Let's have a look at what it says. Measure more pebbles. Measure them at different times of the year. Increase the number of locations. It does say accept reference to random, systematic, or stratified sampling as refinements. Okay, so an easy mark again. Think, then a little bit of maths. Don't get freaked out. Using the data figure 9, calculate the interquartile range of the pebble size data. Remember, the interquartile range is you take out the top 4, take 25%, take off the bottom 25%, and that then the highest from the lowest gives you the interquartile range. Have a look at this. It's one worked out, I hope, down here. And the answer is 6. So the answer is 6 because the top 4 are 12 and higher, and the lower are 6. With the result that you've got a middle point of 6 centimeters. It's the only possible answer. Let's have a look at that. So 1, 2, 3, 4. 1, 2, 3, 4. The answer is 6. Okay, quite straightforward. Where am I with my question? Describe the pebble size data as shown in the dispersion graph. So now you can describe data as shown in the graph. Are they equally distributed? Remember, describe maximum, minimum, trend, anomaly, quote, and locate. Right. What can we see as a trend? Well, they seem to be evenly distributed apart from this anomalously high result. So that I would look to see in the mark scheme. Let's have a look at what it says. And it says down to here, levels marking. Woohoo! So let's look at what they say first of all. Answer must apply understanding of a dispersion graph. Answers may refer to pebble size, frequency, range of pebbles, measures of mean, mode, and median. And all they're looking for essentially up here is the idea that demonstrates clear application of knowledge and understanding of a dispersion graph in describing data. Now, you're not going to get a dispersion graph, so there's no point going too much into this. You're going to get some other graph, which you've got to be able to explain. And then it gets into your fieldwork question, and I'm going to pause the video here and make a part 2 just about explaining for your fieldwork. Okay?